Today, I'm going to show you how to do the opt-in machining on this part that you previously saw in a demonstration. To begin, we go to our program menu and we want to start a new program, so we click on work number, and then I'll assign this a work number that's fit with our on-screen keyboard here. Hit input, and then we want to tell MAZATROL that we want to do a MAZATROL program, and it will ask us to define the part material. And so to start with that, our part is made out of alloy steel. It's 4140. The outside diameter maximum is 3 inches. The ID minimum doesn't have an ID in it, so we'll just leave that blank. The overall length is 3.1 inches. The work face is at 0.1 inches. The RPM, normally you would use this to constrain the chuck maximum speed, but in our case, we don't have any work holding concerns, so we'll leave that with 4,000 RPM. And then we enter our first unit. So the first operation we're going to perform here is a facing operation. And our finished stock to leave on that surface is going to be 30 thousandths of an inch. And so you'll see here, now we have shape number, and that will define the tool that you're going to use as well as the cutting conditions that you're going to use. So it's already populated with a tool that's acceptable for this operation. We're going to leave that there and set our depth. Our cutting speed, we're going to use the automatically populated carbide auto. And then we need to do the same for the finishing pass. So now we'll enter our shape geometry. For our start point in X, we're going to be at the outside diameter of 3 inches. Our start point in Z is going to be 0.1. Finish point in X is going to be 0. And the finish point in Z will also be 0. And so at this point, it's a good point to stop and use our shape check function to confirm that the geometry that we just programmed is accurate. And so you can see at the edge here, we have a highlighted area, and that's where the cutting is going to take place. So we'll move on to our next unit, which is going to be a bar out function. And our cutting point in X is going to be 3 inches. Cutting point in Z is going to start at 0. Our finish in X and in Z, we're going to leave 30 thousandths on both those surfaces to clean up. And then the same shape function is populated again with the cutting conditions. We'll select a pattern here. We're going to use pattern 0 with a depth of 118 thousandths. We'll use our carbide auto for our cutting speed and feed rate, and then do the same thing for our finish pass. Then we get into our defining the outside profile of the shape. We're going to have a linear path with a starting chamfer of 40 thousandths of an inch. Our final point in X is going to be 2.75. Our final point in Z is going to be 2.2. We don't have an end chamfer, and we'll leave roughness blank. And then we'll hit shape end, and we'll go shape check again. And now we can see that we've defined the outside profile of the part as well as the facing operation. Our next operation is going to be a grooving operation. So we'll define the outside of the part. The pattern will be a pattern number 1. Number of grooves, we'll enter 2. The pitch of those grooves is 1 inch. The width of the grooves is 1/2 of an inch. And the finished allowance will leave 30 thousandths again. So again, it's automatically populated with a grooving tool that's acceptable for this operation. We need to input our pattern. We're going to use bidirectional, a depth of cut. And then we'll use our carbide auto feeds and speeds. To define the shape geometry of the grooves, we're basically defining the first section of that groove. So our starting corner radius at the top of the grooves is 0.02 inches. Our starting point in X is going to be 2.75. Starting point in Z is 1/2 of an inch. Our final point in X is 2.25 inches. And our final point in Z is going to be 0.5 inches. We don't have a finished corner radius. We have 0 for the angle, and we'll leave the roughing blank. Again, we'll go back into shape check, shape continue. And you can see now that in addition to our facing and profiling operations that we also have added in the grooves here. The grooving operation is one that's very helpful to have the help menu that we offer. It gives a graphical representation of what all these numbers do. So if you go back into the top line of that grooving operation, hit right arrow over, hit help, you'll see we have pictures that define what all those numbers change. So go back into our program by right arrow over. So we'll go back into our program by right arrow over and hitting Program Edit. Go back down to our 4th unit. We need to do a drilling operation on the middle of the part. So we'll carry it over, T-drill. The diameter of the drill going through this part is 1.58 inches. Again, it populates with the tool that's acceptable for that operation. The pattern that we're going to use is drilling through. Depth of cut, we're going to do this in a single pass, so it will be 3.1 inches. And we'll put that in for those as well. And then our cutting speeds and feeds will again use Carbide Auto and automatically populate those. We get into the start point in Z, that's going to be 0. And the final point in Z will be 3.1. And we have moved on to our next unit, so now we'll shape check again. Shape continue. And we have now added a hole through the center of the part. Go back into program. Our final operation will be a bar in to clean up whatever that drill left over. Our cutting point in X will be 1.57. Cutting point in Z will be 0. And we're going to leave 30 thousandths on both those surfaces just to clean up. Again, we'll define a pattern. We're going to use number 0, depth of cut maximum, 0.118. Cutting speeds and feeds will be populated by the Carbide Auto. And we'll do that for our finishing pass as well. And our geometry here, we're going to be a linear again with a starting corner chamfer of 40 thousandths of an inch. Our final point in X is going to be 1.585. And our final point in Z will be 3 inches. We don't have a corner chamfer at the end of that profile, and we'll leave roughness blank again. Shape end, and then we'll shape check and shape continue. And it's hard to see, but we actually have added a chamfer on at the front of that hole. One thing you can do to zoom in on that is our scale change function. And we'll go shape continue. And now you can see that we've added that chamfer at the front of the part. Our final unit is an end unit. We do not want to continue the program, so we enter 0 here. Parts counter, we don't have one, so we'll put 0 in for that. We want to define our return position as the tool change position. We don't have a work number. That concludes the end unit, so then we right arrow over, program complete. And now we can look at the toolpath function. So this is good to verify where the tool is actually going to enter the cut at. We'll go ahead and draw our part shape. And then if we hit path continue, this is actually showing where the tools are going to be cutting into the part. With that complete, we'll go back into program. And finally, one last thing to look at is the quick MAZATROL function that will help you verify with a 3D model of our part. And so we can see there that the geometry on the screen matches what I have in my hand. We know that that's going to cut the Op 10 part successfully. And that concludes our presentation.